Welcome back to Computer History with Chris Garcia. I am, in fact, Chris Garcia. Today we're looking at Control Data Corporation, from its beginnings through 1965. And you can't really look at Control Data without starting with ERA, Electronic Research Associates. And you can trace its roots back to World War II and the U.S. Navy code-breaking and signal intelligence units. And they had engineers developing sort of special-purpose electromechanical and electronic systems for decrypting, doing data processing, communication analysis, that type of thing. We don't know much about the specifics of it. We know they didn't have anything as sort of robust as Bletchley Park did, but they absolutely had systems, perhaps even fully electronic systems, to deal with cryptoanalysis. Whether these count as computers, I don't know. Now, after the war, the core team stayed together and they formed a research firm. And they called it Engineering Research Associates. And this was really a peacetime version of what they had been doing for the Navy. And that led to developing very, very high-end machines for the time. And they developed systems like the ERA 1101. And what they really were brilliant at was drum memory. And in particular, optimizing electronics to work with drum memory. And again, this was used often in cryptoanalytic work. And it really led to future sort of research, and the 1100X line led to the 1102 and the 1103, which was really the higher performance version of the 1101. The main designer there was Seymour Cray, and optimizing for a known piece of technology, in this case, the drum memory, is really what Cray was incredible at. He understood optimization within constraint. And the constraint here was the available technology of drum memory. Core was not yet ubiquitous, nor, at the earliest point, invented. In 1952, Remington Rand, who owned UNIVAC at that point, purchased ERA. And, Remington Rand had bought Eckert and Mauchly. And that meant they had the UNIVAC line. So most of the machines that were delivered after that in the 1100 line, so the ERA 1102, 1103, and even the 1101, were renamed the UNIVAC 1101, UNIVAC 1102, UNIVAC 1103, and onward and so forth. Now, some people say it went for as little as $1.7 million, which is interesting. ERA was not a big seller, even compared to other what we would consider to be supercomputer companies today. But 1.7 million at the time, probably about 15 million today, still seems very low. And what they were acquiring wasn't the names, because UNIVAC was already the biggest name. They were acquiring the technology, and in specific, the drum optimization technology, because UNIVAC machines had been based on delay lines initially. Now, after the rebranding, they sort of became a difficult portion of Remington Rand, which itself was purchased by Sperry, forming Sperry Rand. Still, they were going on as the UNIVAC line. Now, you still had the teams working on the UNIVAC 1102 and 1103, and so on, that had been initially implemented as ERA groups. But they were now in a corporate structure, which is difficult. No longer were the engineers the upper echelon. There was a whole nother layer of bureaucracy laid upon them. And that made things difficult. So in 1957, a number of them left. And they formed a company called Control Data Corporation. Now, it was incorporated in Minneapolis. And I believe ERA had been in St. Paul mostly. And you had a number of figures. The most important ones were William Norris, who had management experience actually from the Navy, and another gentleman by the name of Seymour Cray. And Cray was sort of the lead designer on all the advanced projects. And in 1959, they announced the CDC 1604, which wasn't delivered until 1960, which was another big year for computers. Because you have to remember, in 1960, you got the PDP-1 came out. 5960, you get IBM releasing machines, including the 1401 and the IBM 1620. Sort of different types of machines, but definitely on that same scale. The 1604 was a 48-bit machine. It was fully transistorized, and it was geared for science. But it was also 100% core memory. Typically, 32K 48-bit words. It was roughly 100,000 operations per second, and it was about $1 million. So it's not an insignificant machine, but it was very much geared towards use in high-performance computing. And in particular, one of the more famous ones was delivered to the Defense Atomic Support Agency, DASA, which would eventually become the Atomic Energy Agency, and then blah, 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 blah. The Navy Postgraduate School, and the Navy bought it largely because, why else, they had an existing connection with Norris and Company back in the ERA days. Now, in 1960, they introduced another line. And in this case, it was a mini computer. And that was the 160, the CDC 160, which was a 12-bit mini computer. And it was often used as a front end for the 1604. Now, while the 160 came out, it was okay, and they co-marketed versions of it with NCR, National Cash Register, which was also doing computers at that point. It had a smaller sort of core, only 4K, but 12 bits doesn't make it a high-performance thing. But then, the 160A came out. And this is interesting because it had usually 8 to 32K, but most installations would go for the 32. It had a 6.4 nanosecond cycle. It had various, I.O. things. But what's really important was while it was a much smaller machine, much less powerful, it could be used in an instrumentation or laboratory setting. And it's really not until machines like the Link, a little bit later, the Lincoln Laboratory Instrumentation Computer, that you really see lab computerization. But the other thing it was used for is as a front end. A lot of people used it to feed their faster computers, or example, the 1604, data. So instead of having to do the I.O. through your big expensive machine, you do your things like offloading onto tape and such, or reading through your 160A. Really important. Now in 1962 there was sort of a sidelight. And this is the CDC 924. And this is a derivative of the 1604, but it wasn't at the same level. It was a 24-bit machine, and it was delivered to Goddard Space, one of the most important NASA agencies at that point. I don't think they were NACA at that point. I think they were already NASA. And they were doing things like test and ground design for the Saturn rockets. And really an important machine for that project. And one of the things that's really key to understand is that the space race doesn't happen without computation. If you saw, what was it? Not Significant Figures. Hidden Figures? The story of how Katherine Johnson got us to the moon. They talk about IBM machines. But IBM was not the only computer company that was making the space race possible. CDC was there too. IBM was less involved as far as governmental contracts in things like weapon design than CDC. But CDC was present across the board to a degree. You had lots of universities that were buying 924s, and was mostly NASA, honestly, and 160s. and they were using them for various things. But really, what started down the line of supercomputer focus for CDC was the CDC 3000 series. And the most important of these was the CDC 3600. This is a big scientific system, 48-bit, was designed for Fortran heavy workload. Now, in 63 is when the first one was delivered. That was to Boulder. And again, the Navy definitely used it. But you were seeing national labs and universities also get it. Oddly enough, CSIRO, out in Australia, which is the Australian Scientific Agency, got one as well. And there were other ones. There was the CDC 3200, the 3500, I think. But the 3600 was really sort of the highlighted machine. I always thought CDC was weird that they always would have the 6 as their sort of star. But, the smaller ones, the 3200, was a 24-bit machine. And it was for commercial, mostly. And it only had 800 kilohertz, about 1.25 nanosecond cycle time. And it could get almost 100K. 96K was usually the most people would do. You had the 34, which was sort of a streamlined version of the 36. It was also a 48-bit machine. But in 65, CDC kind of went all out. They delivered a low-end version of the 3600, the 3100, that CERN actually bought. It was a bit later for a project called Focus. And then the 33, which was also a 24-bit machine. But it was really about government business work. So it wasn't really doing design stuff. It was doing more like logistics. Of course, you had the 38, which was for super heavy scientific loads, but it was less broad in scientific application. But it had 128K of core, and it cost about 1.9 million, which I want to say is almost 17 to 20 million now. But CDC finally had conquered a market that off of the US, outside of the government, that was really important. And the 3000 series would have been where most companies focused. They would have seen that this is where supercomputing is. But Cray had already, and Cray was their principal high-end designer, Cray was already working on what would be the most important of the early supercomputers. And that was announced in 1964, first delivered in 1965. This was the 10 megahertz. That's insane for the time, if you look at what was the fastest machine prior, which I believe was Stretch from IBM. But 10 megahertz at that point was considered crazy. It was a massive jump. And this is the 60-bit CDC 6600, the fastest computer in the world until CDC topped itself years later. And a lot of companies were fighting to get the next fastest machine in the world. And Los Alamos and Livermore were sort of famous in that realm. And I believe Los Alamos won with the 6600. I think Livermore won with the 7600. But here's something interesting I think that is great. The 6600, fastest machine in the world, could do 3 million floating point operations per second. And at the time, that was nuts. But it was also not necessarily focused on doing floating point arithmetic, though it started to. And when you have a machine that is operating at these speeds, what is becoming possible is use at the super high end of computation. And that made what we were able to do in researching nuclear building. So nuclear weapon design in particular, but also nuclear plant design at the same time possible. And great innovations were made because of the introduction of the 6600. What it did was it made it possible to go further and further into math that they knew they would need in the old days. Edward Teller was complaining that all of the designs during the Manhattan Project were hindered by the fact that the theoretical math existed, but the ability to do the math did not, at least not in a reasonable time frame. And it's no surprise that Teller, who was at Livermore, would be absolutely on the cutting edge of delivering devices and using these machines. But that wasn't the only place they were used. Atmospheric research absolutely used CDC machines for years and years. It doesn't quite get the praise it deserves for its actual work in atmospheric research. A lot of research that we'd sort of see today as environmental, things like ocean studies, were partially done, and hydraulic studies, or hydrolysis studies, I can't remember what the technical called when you're looking at flooding. All of this made possible because of the speed achievable through the 6600, and the 3600 to a lesser. But the 6600 changed the world. Okay, what's coming next? Well, I'm doing this episodes on the IBM 360 series, the PDP-8 in specific, and sort of the first set of follow-ons. And then I'm going to do one on supercomputing in the late 1960s. And that's going to be very different. And eventually I'm going to do computer graphics. I know, I've said I'm going to do various things. Just go with me, please. I'm hoping to keep the time frame between episodes as short as possible. But I'm Chris Garcia. Thank you for listening to Computer History with Chris Garcia. You can help us keep going by supporting our Patreon. And that's 3min Modernist on Patreon. That's the number 3, MIN Modernist. And keep an eye out for our other podcasts that we'll be doing, which is 3-Minute Modernist, Registry, which will have an episode coming up about the National Film Registry, and my newest one, Food Criminals, which is where I am reading chapters from my book, the upcoming version, Food Criminals, Last Seeding. So I hope you'll stay tuned. Thanks for listening.